Hello everybody, my name is Cameron Snow, and in this video series I'm going to be talking to you about geological risking, and specifically how is it we quantify uncertainty in our exploration prospects. Alright, so normally I teach this as part of a course for students, and I'm available to do that. I can come in-house to your company and present this course. And this course is going to be making its debut on the Saga Wisdom platform later this year. And so I'm not going to go through the course in this video series, but instead I'm going to hit on some of the highlights, discuss what is geological risking. But I'm going to spend more time in the GeoRiskX software explaining the concepts and why it is so important that we take a modern approach to risking. All right, so let's look at a few questions here. So before we get started, it's important for us to understand that geological risking is something where we use the language of probability and statistics and mathematics. There will be some terms that I use in here. So if you have questions, leave those in the comments and we can go deeper into those. Happy to go through the feedback with you there in the comments section. Also, if there's something that seems to be unclear for a lot of people, we can go in and do a separate video just for that. But it's important to know that there will be a lot of language in this module, in this series, where we talk about probability and statistics. Before we jump in, I want to give you a little bit of information about my background. So why should you listen to me when it comes to geological risking? Well, I'm a geologist with 20 years of experience, and I've had the benefit of working across many of the major hydrocarbon basins, whether it's in North America, South America, Europe, Africa, or Asia. And my experiences really range from everything from frontier wildcat exploration to infill development drilling. So I've seen the full upstream economic cycle here. Now, my real expertise lies in two areas. First, it lies in reservoir characterization, where I'm an expert in petrophysics and geological modeling. If you want to learn more about petrophysics, check out the Dynamics YouTube channel and the dynamics.com website. That is where I go into extreme detail on petrophysics. However, for the purpose of this, we're going to be focused on GeoRiskX, which is a modern cloud-based risking platform that we can use to quantify risk across our exploration portfolio. So what is geological risking? So if you're working in exploration, you likely hear things like, oh, this prospect has a 30% chance of success. This prospect is, has a 40% chance of success, and it has a mean volume of 200 million barrels of oil in place. So, you hear those type of terms, and those are the product of geological risking, but what actually is it? Well, geological risking is the process of evaluating the likelihood of each hydrocarbon system component being present. So let me give you some examples of that to make this a bit more clear. So what are the hydrocarbon system components? Well, we have things like the structure, the seal, the source, the charge, and reservoir quality and presence. So when we talk about the chance of success, we're talking about what are the chance of success of each of those components being successful. And we'll give them each an independent risk. So we might say, oh, there's a 90% chance of success with respect to the structure. So, maybe we've looked at seismic data, we've done an interpretation, we've looked at that part of the system. We say, okay, well, it's 90% likely that there is a structure that's here that is trapping hydrocarbons. okay, well, what is the likelihood that we have an effective seal on that trap? Whether or not it's top seal, lateral seal, cross fault seal. Okay, is there a 70% chance there or a 90% chance? What about reservoir presence and quality? So we go and we look at the offset wells and the depositional environment, and we would generate a likelihood for that. And as we go through each of these components, then we are able to generate an overall likelihood of success or chance of success for our well as a whole. And so that's what goes into an analysis when you hear something like there's a 40% chance of success. Um, and that's one half of the story. The other half of the story comes from the range of volumes that are in the ground. So anyone who's worked in the subsurface knows that you're not just putting a single number on a play. You're not saying, oh, there's 200 million barrels in place. Or if you are saying that, you're being a little loose with how you do interpretations. It's more that there's a range of outcomes that maybe go from 20 million barrels up to a billion barrels. Now, we once again come up with a low end, a mid range, and a high case. So we'll often talk about what's our P10 volumes, our P90 volumes, our P50 volumes. Uh, and that's how we like to couch the range of volumetric outcomes. So you'll often hear it expressed as a P50. The P50 outcome here is 200 million barrels in place. And so then what we can do is we can combine the risk assessment and the volume assessment to get the range of potential outcomes that uh, we would have for a prospect, and then we can apply this across an exploration portfolio to calculate, uh, what our expected volumes are from that portfolio. You know, how many successes should we expect out of a portfolio of wells, and so on. And this is a very valuable process for two reasons. One, it helps us understand which prospects we should allocate capital to. Because if we can understand the combination of risk and volumetrics, then we can understand better, what our likely return on investment is for certain plays, and we can try to balance out, let's say lower risk, lower reward opportunities with some medium and higher risk opportunities that have maybe larger potential with respect to the volumes. So, geological risking is something that is almost omnipresent across exploration, but the thing is, risk is not real. Um, it's not something that we can go measure. You can't walk up to your drilling location and stick a tool in the ground and say, oh, there's a 40% chance of success. That's just not how it works. So it's not something that we can measure. It's something that we estimate. And after we've drilled the well, in general, we have the answer. So the risking goes away. So before a well, we might say, oh, there's a 35% chance of success. And then we drill the well, and the well is a dry hole. Well, that at that point, there is a 0% chance of success. It is a dry hole. So, there is no debate. Or we've drilled it and it's a discovery. Now there is a 100% chance of success there with respect to the geology. Now there may still be questions about the volumetrics. There may be undrilled zones. Maybe we only drilled the shallow zones and there's still a deep zone that we've not evaluated, so maybe there's still some risk with respect to that. But in general, risk is something that only exists before we drill the well. And after we've drilled it, it's no longer an estimate. It is just a fact. Um, so really, risk is a construct about of our opinions and our beliefs about the subsurface and what's going on, you know, below ground. And when we make this estimate of risk, Of course, we love to do this on data. So you should analyze your data. You should look at the seismic data. You should look at available well data. You should look at outcrop data. And we should try to base our risk on that. But it's also based on our experience and on analogs. So a lot of times you'll hear people refer to geological risking being as much of an art as it is a science. Now, I like to believe that it should be more in the camp of science, but it's just science that has uncertainty around it. So we are going to apply mathematical concepts to help us quantify this. And so that, those concepts, even though they may be a little fuzzy and they may be imprecise, still offer value. And this is demonstrable. You can look at historical evaluations of risk, and this really, plays out that, we do know what we are doing here. All right, so that's where I'm going to call it quits for this video. In the next videos, I am going to jump into the software and go through why it is important to take a modern approach to risking using software. All right. Thank you very much. And if you have any questions, you can always get a hold of me at cam@georiskx.com. Thank you.